Okay, so this is a video on how to make decisions using decision trees. Okay, decision trees factor into is useful when it factors into two things like what is the when you know what is the reward associated with your decisions, and you also know what is the probability of each outcome. So I'll explain what this means. But so it factors both possibility, reward, and the risk of whether you will an uncertainty or whether you will get the reward or not. So for example, in the situation where you need to decide whether to organize a party indoor or outdoor, so your decision is affected by the weather. So let's say if the weather is sunny, for example, so let's say if you decide to go outdoor and the weather is sunny, then the utility to you is 5. Okay, you are very happy outdoor, you prefer outdoor to indoor with the sunny day. But if it happens turn out to be a rainy day, and then your utility becomes negative because you won't be able to carry out a party now because of if you plan it for a rainy day, then you are going to get a negative, you're going to be unhappy. Alright, so but if you decide to go indoor, the reward to you is change. You go inside to do if you go indoor and the weather turns out to be sunny, so you're happy, but not as happy as if you were outdoor. Alright, and if you go indoor and it is rainy, then you are slightly more happy than you are but then it is a sunny day, because maybe the weather is cooler and it's better to stay indoor because you're happy that you are not outdoor. So you are happier than if the day is sunny if you stay indoors. So you decide, these are the utility that you decide for yourself. You decide how happy or how sad you will be if in each scenario, and then you give it a score. But then based on the weather forecast, you will think that okay, in this area there's a 2/3 chance that it will be sunny. But because the weather forecast gets wrong, for example, you're in the weather forecast that you rely on is always mistaken 1 out of 3 times about the weather. So you would say, although the weather forecast is sunny, but there's a 1/3 chance it turns out to be rainy. So this is the chance of each scenario, this is the probability of each scenario. So in this case, so sunny and rainy, so rainy, and no matter in each decision, the chance of it being rainy is still the same. It has to be 1/3, and the chance of it being sunny is, these two must be the same. It couldn't be just because you choose it to be outdoor, the probability of the day being sunny wouldn't change based on your choice, because your choice will not affect the weather, right? So the weather is affected by the reliability of the weather forecast and what they forecast the weather to be. So how is this probability and this reward useful? So usually when we think, if our brain is not powerful enough to consider all these factors all together, so we use a decision tree to calculate what is the better choice. How do we do that? So the way to do it is to do this. Okay, so the outdoor decision, I'll give a score to the outdoor decision using a calculation backward induction method. I'll calculate from the back. So because there's a 2/3 chance of my utility being 5, so I'll take 2/3 times 5. This is here, 2/3 times 5 plus, but I need to add to the possibility that it will be a rainy day. So 1/3 multiplied by the utility of a rainy day, so 1/3 times -1. So when I add these two together, this times this plus this times this, I get a 3. So I score 3 here. So the outdoor decision has the expected return of 3. Okay, so and let's say if I go indoor, okay, there's a 2/3 chance of the utility being 2, so I take 2 multiply by 2/3, and I take 3 multiply by the probability 1/3 is will be rainy. There's a probability of 1/3 that I realize this utility, so I take 1/3 times 3 for here, and then I'll add these two up. I add them up and I get a utility of 2 and 1/3. So considering all these factors together, so this calculation allows us to consider all these factors together, and then since 3 is a greater utility than 2, and I'm more likely to be happy. I'm more likely to be happy outdoor than indoor. It takes into account both the reward and the probability. So because I could be so much happier. I could be so much happier if it's outdoor and sunny, that I'm willing to take a bit more risk. Okay, so then that means it factors everything 3, because 3 here is greater than 2 and 1/3 here. I'll take this decision, which is to go outdoor. Okay, so then we move into another example where, okay, I'll break this down. I think I'll break down the video into a few parts so that, okay. So this is the now we consider this scenario. Okay, let's say if a business, this is applying on a business. So let's say to import or don't import goods to sell. So I have 2 decisions to make, whether to import or don't import. I need to decide. If I don't import, I do not lose any money, but I also don't earn any money, right? That is the utility I get from not importing. So whether the goods doesn't sell will sell or doesn't sell, actually doesn't matter to me. My money is still, the money I earn or lose will still be 0. So if I do import, then there are other factors to consider. So let's say if I do import, if it doesn't sell, if I import the goods and it doesn't sell, I'm going to lose money. I'm going to lose $10,000. If I import and it does sell, I'm going to earn $50,000. But there is a 60% chance that it will sell based on market research. That you collected the information that there's 60% out of every 100 100%, for example, or 1,000%, you have most of like out of every 10, perhaps every 6% say they will buy. So perhaps you assign a probability that of 0.6 that the good will sell, and then the good, there's a probability of 0.4 that the good doesn't sell. So based on this, right, I will use the same type of calculation as in the first part of this video. I'll take minus 10,000 multiplied by 0.4, I'll get 4,000, and I'll take 50,000 multiplied by 0.6, I'll get 30,000, and I add these 2 values up to derive the value at this decision to 26,000. So 26,000 compared to 0, 26,000 is of course more, so I will choose to import. Although there's still a chance of me losing $10,000. I'm not saying that just because, but of this, but the expected return is higher. That means factoring in taking into account the probability and the potential reward, I think the expected return is still higher to import. Although the expected return is different from the realized return. In actual fact, it could be you losing negative $10,000, but because of the potential upside and the probability of the potential upside fact, and so you would overall you will still favor the decision. So decision 3 is taking care of 2 things. It take care of uncertainty effect and factor also about the potential reward. So 2 things they consider together. So in a single decision, the decision 3 may inform you wrongly. Okay, and after many decisions, if you use the decision 3 for many decisions, over the long run you'll be better off, because the expected return factors take into account probability. So over the long run, the whatever is more probable is likely to be more likely to be realized. So therefore, if you use decision trees in many of your decision, and it is more helpful than if you use it just for one decision. In one decision, it may inform you wrongly, but overall a long time, right? This will balance out. All right, all the chances will balance out. It's just that you may be lucky once, right? You may be unlucky once, okay? But over a long time, if the probability is on your side, right, then it will balance out. The negative and plus will balance out, but the plus will be more than the negative, because of you are making decision based on factoring into all this already. So That's but also take note that the decision tree depends on a few things. The accuracy of the input. Okay, so you think that there's a 60% chance that you will sell based on your market research. Means your market research must be accurate in the first place. If you're not accurate in the first place, if it's a bias sample, then your market research may inform you wrongly. So similarly, the potential cost or the reward you assign must be accurate. Okay, so all this must take into account. And also, yeah, you must draw the decision tree as rationally as possible. So for example, don't import may not be just the cost may not be $0. There may be some opportunity cost involved. Or let's say if you don't import but your shop is still open, you still need to pay rental, and then you need to make the decision of whether to close down the shop or not to close down the shop. So that means it has to stretch further than the scope of this decision tree. So making the decision of closing down the shop or keeping the stock is also a costly decision. So you have to factor in the cost as well. So we don't know. So therefore, yep. So you have to use this decision tree skillfully. So some of the thing is not so straightforward, right? And then now we come to the third scenario, where you are making a decision between whether let's say if you like a guy, and you are making a decision of whether to tell or don't tell the guy you like him or not. So let's say, okay, for example, then it starts with your decision, tell or don't tell. Let's say if you don't tell, then maybe the utility to you is zero. That means you won't feel better or worse than you are currently. Okay, but if you are telling, then there is a 1/3 chance that he will reject you. Okay, based on maybe this information, right, could be based on, okay, the rejection rate he give to maybe every three girls that approach him, he reject one of them and accept two of them. Right, so this is a very, okay, that's not a way to get the probability lah, but whatever way, based on your estimation of your chances, you should decide the probability. Maybe if you are, or take it another way, maybe every one out of three guys dislike you, but every two out of three guys are favorable to you. Yeah, okay, so maybe you are a very popular person and every two out of three guys would accept you to be their girlfriend. So that's your estimation. So then you input this probability. So what is the reward? Reward will only be at the very end. Okay, will only given at the very end. So let's say if you reject you, and you are still remain as friends, the reward to you is -1. So I mean, that means you are a bit unhappier than currently, right? And then because you realize that, okay, but the utility for different people may be different. Maybe someone will think that it's better to tell, even you still remain as friends, then you let it out, or it's better to let the secret out. So then the utility may change to 2. So you have to assign your own utility. Okay, you don't decide for yourself what is the utility score you give to each scenario. It's not no one else can decide for you. So then after you go to, let's say if they reject you and you're no longer friends, maybe you feel even sadder than this case where you still remain as friends. So let's say then you'll be -2. And then what if he accepted you and to be his girlfriend, and then they break up later? Maybe you are even sadder than the earlier 2 scenarios. But depends, somebody may be happier that they had a chance to be together, and this could be a false score or things like that. So I'm just giving an example of how to give utility. So, and then what if they accept you, and then after that happily ever after? That's the best scenario. That's 10. So let's see whether then, based on all this, should we tell or not. So it also depends on the chances of, actually, based on common sense, also depends on how likely this is, right? So okay, so for example, there is if you tell, then there is a 2/3 chance that you will be accepted. and there's a 2/3 probability that you accepted, and there's a 4 out of 5 probability that you will be happy ever after. So for example, there are every out of every 5 couples in your school, 4 of them turned out to be happy ever after. So you believe that you shouldn't be more unlucky than the rest. So there's a 4 out of 5 chance that you'll be happy ever after. So this could be a way to decide what's the probability here. Then after that, then of course this must add up to 1. There are only two scenarios, so the probability should add up to 1. If this is 4/5, then this should be 1/5. Okay, there could, unless there's another possibility, right? Then the probability, all these 3 probabilities must add up to 1. But now there's only 2 probabilities, so these 2 probabilities must add up to 1. And similarly here, these 2 probabilities across the branches has to add up to 1. Half plus half is 1, right? And so 1/3 plus 2/3 is 1 also, right? Probability reject and accept must add up to 1. There could not be other possibilities. Maybe there's a third possibility that he will give you an ambiguous reply. Okay, if you want to consider that scenario, then you add a probability to it, and you must change these 2 probability to accommodate that as well. That means all the 3 would have to add up to 1 now. But now there are only 2 cases, so 1/3 plus 2/3 has to add up to 1. So now we begin to calculate. So we work from the very backward. So we don't have this at the start. We don't have these scores at the start. This score, and this score we don't have at the start. We base on what we have finally in each scenario. We assign the utility first, and then we work backwards. So what is the utility here? The utility here is obtained by taking 4/5 multiplied by 10 plus 1/5 multiplied by -5. So to get this utility, which is in the first place we don't have it, in the first place we only have this 4 utility at the very end. We only decide this 4. So then we work backwards to arrive at this probability. So I take 1/5 multiplied by -5 plus 10 multiplied by 4/5, and then I get a 7. Okay, so then I write this 7 over here. Then to get this probability, I'll take half. Note we work backward from the very last node, right? So these 2 nodes, so half times 1 minus half times -2. No, half times, so this one is half times -1 plus half times -2. I'll get the -3/2 here. So I need these 2 first before I can work out the probability, the expected return on this decision. So I need the utility, expected return on each subsequent branch first. Let's say there's a 3 branch here, then I take the probability of this branch times the expected return on this branch plus the probability of this branch times the expected return on this branch, then plus the probability of this branch times the expected return on this branch. All these 3 add up, then I'll get this utility. But now there are only 2 branches, so I take 1/3 multiplied by the probability of this branch multiply the expected return of this branch, 1/3 times -3/2 plus 2/3 times 7. Then I'll get 25/6. So 25/6 is larger than 0. So I should take this decision to tell the person, and I'm more likely to have that to be happy than not happy. More likely, but doesn't mean certainly. So let's say if in this case, right, if you figure out all the utility correctly, and you should be happy with your decision no matter what it turns out to be. So in this particular scenario, maybe the decision tree would inform you wrongly to make you make the decision, maybe because this is still a possible chance. You see, it's still possible for this scenario to happen. Okay, it's still possible for this scenario to happen, but because of the low probability, you can tolerate low probability of this happening. Most likely it won't happen. So you factor into both the uncertainty and the reward. So in order to make this decision, so in a single decision, if it doesn't work out to be very well for you, but consider if you use this method in another decision and also in another decision, so in the long term, all the plus and minus will balance out, and you will likely to be more happy overall. Okay, so because of probability realizing itself in many tries, so and therefore uh if you constantly use decision trees in your decisions over a long run, you will live a happier life. That's provided you are good at drawing decision trees, you're good at collecting information about the probability, and you're good at determining the your utility in the manner of assigning a mathematical score on it, the numerical score on it. So for example, if you are actually very happy but you do not know what is the actual, you are not good at assigning an actual number to it. For example, you may assign 9, or someone may assign 10, or for the same level of utility, same level of happiness, because happiness is something that is hard to measure by numbers. So you could get it wrong, even if it is you are the person experiencing the feeling. So therefore that's some of the caution to use when to take when using decision trees. But decision trees is also good for you to use for persuading others. Let's say if this decision is made for a business, and you write down your calculations in a decision tree and present to your bosses and your colleagues, it's easier to convince, usually easier for them to understand your thinking process, to discuss over what is the actual utility that you should assign, or what are the actual chances. Let's say when you join the decision tree, it also forces you to think about the probability of each outcome. Let's say if you're not sure about the probability of each outcome, then you should go ahead and collect information about it using past statistics, analytics, or things like that to arrive at the probability. Then you can make use of decision tree to make a decision. That's where statistics comes in as a useful skill. And yeah, if you need help with decision trees, feel free to contact me at info. If you need help in using decision trees to make decision, yeah, info@hour.com, or you can visit my website www.hour.com. Or okay, I will be writing a book on decision tree. Is a small book, small ebook. You will able to find on Google Play, or my website. Okay, so that's it. Oh, I